Hello everyone, welcome to my channel and welcome to another video on integration. In this video I have one integral that I would like us to look at. It's the integral of x to the power 4 plus 2x plus 2 all over x to the power 5 plus x to the power 4 dx. Now this is one of those integrals where if you look at it, it's very difficult to know where to start from, because if you differentiate the denominator with respect to x, you don't get x to the power 4 plus 2x plus 2 dx. That means there's something else that you need to do. So we can't use substitution directly here. There's something we need to perform. And of course, looking at the denominator, the common factor is x to the power 4. So factorizing this would be the starting point as follows. So we have the integral of x to the power 4 plus 2x plus 2. We're dividing this by x to the power 5 plus x to the power 4 dx. Now this, like I said, is equal to x power 4 plus 2x plus 2 all over factorizing x to the power 4, and we have x plus 1. If you divide x to the power 4 in there and there, you get this expression, and then we have dx there. Now looking at the denominator, it is suggesting to us that we have to use partial fractions. So we're going to decompose the integrand by using partial fractions decomposition approach. So here is the story. Now I'm saying we have x to the power 4 plus 2x plus 2 all over x power 4 x plus 1. This will be equal to the linear part. The numerator will be a constant a all over x plus 1 plus the fourth degree expression, that's x power 4. The numerator will be a third degree expression, so it will be bx. There's always 1 degree less in the numerator. X power 3 plus cx squared plus dx and then plus e. That's a general term when you look at a cubic function or third degree expression. In the denominator you have x power 4. Right. Now we have to simplify the right hand side. The LCD common denominator is just the product of these two. So what we have now is x power 4 times x plus 1, like that. And then we divide this expression into that. The answer is x power 4 times the numerator. So it is ax power 4 plus x power 4 divided in there. The answer is x plus 1 multiplied by the numerator. So we have x plus 1 times bx cubed plus cx squared plus dx plus e, like that. On the left hand side, remember, on the left hand side we have x power 4 x plus 1 in the denominator, and the numerator is x power 4 plus 2x plus 2. Now these are two fractions that are equal. Denominators are equal, therefore numerators must also be equal. So I can say here, therefore, or this implies, it implies that x power 4 plus 2x plus 2, this must be equal to the numerator there, which is ax power 4 plus x plus 1 multiplied by bx cubed plus cx squared plus dx plus e. I'm going to expand that part. This is going to be equal to ax power 4 plus multiply x by this. It will be bx power 4 plus cx cubed plus dx squared plus ex. Then multiply 1 by the whole of that expression. It will be the same expression, plus bx cubed plus cx squared plus dx plus e. On the left hand side we have x power 4 plus 2x plus 2. Now I'm going to have to factorize the right hand side. First of all, bring like terms together. These are like terms. If you factorize that out, you're going to get a plus b outside x power 4. plus the next part is going to be b plus c, this part and that part. So b plus c outside x power 3. The next part is going to be c plus d, this part here and that part, c plus d outside x squared. The next part is going to be d plus e outside x. There it is, d plus e outside x, and finally we have e there as our constant term. That will be equal to, if you allow me to rewrite this, I can rewrite it as 1x power 4 plus 0x cubed plus 0x squared plus 2x plus 2. That's what we have. Let me clean up here a little bit, like that. Now, so that means we're going to look at this coefficient of x power 4 equate to that coefficient, and we take that equate to 0, we take that equate to 0, and this part here equate to 2, and finally e will be equal to 2. Taking us to the next page. Let me move this one down. Right, so basically what I'm saying is a set of equations that we are going to produce from here. And here is a set of equations we're going to produce. It is, the first part is a plus b equals 1. A plus b there equals 1, coefficient. And then we're going to carry on. Next one is b plus c equals 0. B plus c equals 0. And then we're carrying on. We have c plus d equals 0. C plus d equals 0 there. And then we have d plus e equals 2. D plus e, there it is, coefficient of x equals coefficient of x on the left. And finally, we have e equals 2. Constant term equals constant term on the left. Now we're going to move in the reverse direction, taking e equals 2 here, it will be d plus 2 equals 2, because remember e is 2. That means subtracting 2 from both sides, d will be equal to 0. Taking d equals 0 into this column here, we have c plus 0 equals 0. That tells us c equals 0. Taking c equals 0 into that space there, we're going to have b plus 0 equals 0, and therefore b equals 0. B equals 0, taking it into the first column there, it's going to be a plus 0 equals 1, and that tells us that a is actually equal to 1. So we have two equations that are critical here, a equals 1 and e equals 2. That means our integral, this one here now, is going to be transformed as follows. We're going to say, therefore, the integral, which is x power 4 plus 2x plus 2 all over x power 5 plus x power 4 dx. This integral is exactly equal to the integral of, watch this out now, 1 over x plus 1, because a equals 1. And we're here now, substituting into that place. The whole of this part collapses. We are left with e over x power 4. And what is e? 2. So this will be 1 over that plus 2 over x power 4 plus 2 over x power 4. And we have dx. Let's distribute dx and the integral sign there. We have the integral of 1 over x plus 1 dx plus the integral of 2 over x power 4 dx. Now, working on this part, you'll agree with me that this is just natural log of x plus 1. And then plus, take 2 out, the integral of 1 over x power 4 dx. Rewriting this part here, we have natural log of x plus 1 plus 2 times the integral of x power minus 4 dx. Remember laws of exponents. So what do we do next? We use power rule there, taking us to the last page, page 3. Let me go to page 3 now. Okay, page 3, here we go. This is our page 3. So there is our integral. We put it down here. Right, so now I'm basically saying, we are now saying that integral equals natural log of x plus 1 and then plus 2 x power minus 4 plus 1. We must take this and divide there, minus 4 plus 1. And then we have to say plus c because we're dealing with an indefinite integral here. So let's rewrite this part then. This is equal to natural log of x plus 1. And then this part here is going to be plus 2 x power minus 3 all over minus 3 plus c. Again, rewriting this part, you'll agree with me that this is just natural log of x plus 1 minus 2 all over 3x power 3, and then I'm going to have to say plus c. Remember the minus, we change that sign to minus, and in the numerator I have 2. The x power 3, when it comes down, you negate it. So what is minus minus 3? The answer is going to be positive 3. So the power becomes positive 3 in the denominator there, and of course you have a 3 there. So this is the final solution to this integral. If you are new to this channel, support us by subscribing, sharing these videos with friends, and giving us feedback. We truly value your feedback. All right, I'll see you in the next one.